I was asked to provide some more examples doing long division with polynomials. So we're going to go over that. Quickly, just as a reminder, let's say you were doing 23 into 700. How would you do that? You say, well, how many times does 23 go into 70? And hopefully you get 3 times, which you write up here. But you can't just do 3 times 20. You sort of do an estimate. Probably 2 goes into 7 3 times. Hopefully that's sort of how you learned how to do this. But it's an estimate. But I really have to do 3 times 23, the whole thing. And then, rather than add 69, remember you subtract it. And we would then have 1, and then you bring down the next thing here, right? And 23 does not go into 10 at all, right? 0 times, so you put a 0. And then you have to do 0 times 23, and then you subtract it. So I have 10 again. And when you get a number smaller than 23, you stop. That's your remainder. So the answer to this problem is 30 remainder 10, or 30, and what you do is you take the remainder 10 and put it over what you divided by, plus, remember this means 30 plus 10 23rds. All right, now we're going to contrast that with long division. If I were to do x squared plus 5x plus 1 divided by x minus 2. So you put x minus 2 into x squared plus 5x plus 1. So the difference here, instead of thinking of 23 goes into 70, what I'm thinking of is what to multiply the first term outside here. The x times what will give me x squared. All you have to do is look at the first term. So x times what will give me x squared. And that we write up here. All right, so you have to look at the first term here outside and the first term here and decide exactly what to multiply to get the x squared, the first term in here, which is an x. Now, look at how I did it over here. Remember I did 3 times 23? I do the same thing here. I do x times, not just x, but I have to do it by the whole quantity, x minus 2. So I have to do x times x, which is an x squared, and also x times negative 2, which is minus 2x. And you want to line it up under its like term. So you're doing the distributive property, correct? Now, over here, what's the next step? I subtract. Okay, I don't want to add this. I want to subtract it. Be careful. You're subtracting both terms. So you're subtracting the whole thing here. Now, you might be able to do that in your head and say x squared minus x squared is 0, and 5x minus a negative 2x is 7x. Or, if you like, you can go ahead and just show the changing of the signs. So if you want to change this to adding the opposite, you could add and you're going to change to the opposite signs inside. Does that make sense? So you could change signs that way. Now I've got, these will always be the same, and then you're subtracting them. So you're going to cancel out. 5x plus 2x is 7x. Next step, bring down the next term, which is plus 1. And we repeat the process. I have to figure out x times what will give me 7x. Remember, you always look at the first term here. What are you going to multiply it by to get the first term here? That's going to be 7. So that gives me a plus 7. But I really then have to multiply 7 times the whole quantity out here. So I have to do the distributive property. 7 times x is 7x, and 7 times negative 2 is negative 14. All right, and we don't add. Remember, we need to subtract that whole thing, which is the same as adding the opposite. If you want to change it to adding the opposite, I can go plus and negative, and that's going to change to a positive. You just change any signs inside there. These will cancel, and I have 1 plus 14, which is 15. Now 15, x times what is 15? All right. If whenever you get something with a smaller degree, remember the degree is the exponent on the variable. Well, there's no x left. That tells you that's your remainder. So this is the remainder for this problem. All right, so how do we write the answer to this problem? Well, if you want, you could go ahead and write remainder 15 up here. But usually that's not how we write the final answer. We write it as the x plus 7 is what we got up on top, plus, and then you write the remainder in the top of the numerator, and in the denominator you write what you divided by, which is x minus 2. Just like if it was, you're dividing by 3 and you get a remainder of 1, you'd write 1/3. But instead of putting it right next to the 7, you have to write it as plus, because these are algebraic fractions. So this is the answer, written in the right form. Now let's check this. Check. Normally when you check, you multiply your answer times what you divided by and add your remainder. That's exactly what we're going to do. So we take what we're dividing by, the x minus 2, and multiply it by this x plus 7. So we have x minus 2 times x plus 7, and then we're going to have to add 15. And we want to see if when we do that, do we get what was underneath the division bar to begin with. So we could do the FOIL method here. X times x is x squared. X times 7 is plus 7x. Negative 2 times x is minus 2x. Negative 2 times 7 is negative 14, and add 15. Now, if you've got 3 terms by 2 terms, you might want to use the box method. You won't be able to use the FOIL method, so you might take a little bit more space to multiply it out. But let's go ahead now and just add like terms. We have x squared plus 5x plus 1. And does that match? Yes, it checks. Therefore, this is the correct answer. So it does take a little doing an example in long division. So a couple things to remind yourself of doing is when you do the minus, it's easier, I think, to change it to plus and change signs. So we put the parentheses, do this change of signs here, since subtraction is adding the opposite. Also remember to write these in descending order. So you don't want to put the 5x plus x squared plus 1. A hint is, whatever the degree is here, this is 2. The highest power underneath here is 2. That means there should be 3 terms. So if you've got a missing term, you're going to put a 0 for that. So just a little bit of a setup. I'm going to show you a couple setups here. Let's say you were doing x cubed minus 8 divided by x minus 2. You would have x cubed. The highest degree is 3. I should get 4 terms. So you have to put something in for the x squared term. What's the x term? Not there. You have to put in something for the x term, and you have a minus 8. Let's see if I can get through this fast enough before I run out of time on YouTube. So x times what will give me x cubed? X squared. Now I have to multiply it by the whole quantity. Remember, x squared times x is x cubed. X squared times minus 2 is a negative 2x squared. Put it under the x squared term, minus 2x squared. Now, here's the trick. You're subtracting that whole thing. So you want to add the opposite. So change that to a negative, change that to a plus, and now add. So that's 2x squared. And bring down the next term. So x times what will give you 2x squared? 2x plus 2x. Remember to always put it whether it's a plus or a minus. So that gives you a plus 2x squared and a minus 4x. And again, you have to subtract when you do division. So you're going to change that to a minus and that to a plus, which gives you 4x minus 8. All right, x times what will give you 4x? 4. So I've got 4x, and 4 times negative 2 is minus 8. And now we're going to subtract. So I'm going to add and change signs again. Great. 0 denominator. Cool, no remainder. So x cubed minus 8 divided by x minus 2 is actually right here. X squared plus 2x plus 4. Now to check it, you would multiply x minus 2 times x squared plus 2x plus 4. I don't have time to do that, but I'll show it to you. Alright, so to check, we have to do x squared plus 2x plus 4 times x minus 2. Here it is. I used the box method, and it was equal to x cubed minus 8. So that means that was the correct answer, x squared plus 2x plus 4.